Have you ever looked up at the night sky and felt impossibly small? Not in a frightening way, but in a way that somehow makes everything lighter. The stars you see tonight are the same stars your ancestors gazed upon thousands of years ago. The light touching your eyes right now began its journey before you were born, before your parents were born, perhaps even before humanity learned to speak. And yet, here it is, arriving precisely in this moment, as if it had been traveling all that time just to meet you. But here's what keeps me awake at night. What if those stars aren't just distant suns? What if they're clocks, measuring something far stranger than time itself? Tonight, we're going to follow that question into the deepest mystery of existence, not with formulas or facts alone, but with wonder. So find a comfortable place, let your breathing slow, and come with me into the space between heartbeats, where the universe whispers its oldest secrets. Before we drift into the cosmos together, if you're moved to do so, a quiet like or a gentle subscribe would fill my heart with gratitude. It's a small gesture that keeps this little sanctuary alive and reminds me that somewhere out there, gentle souls like you still seek these quiet moments of wonder. Now, let the journey begin. The stars you see tonight aren't really there, not in the way you think. When you look at Sirius, the brightest star in our night sky, you're seeing light that left its surface 8.6 years ago. When you gaze at Betelgeuse in Orion's shoulder, you're witnessing light from 548 years in the past. And the most distant objects visible to our telescopes, the ancient galaxies captured by the James Webb Space Telescope, they show us the universe as it was over 13 billion years ago, when it was barely 500 million years old, still in its cosmic infancy. This creates a peculiar truth that sounds impossible, but is absolutely real. You have never seen the present moment of anything beyond Earth. Not once. The moon you see is 1.3 seconds in the past. The sun, 8 minutes and 20 seconds old. Even the person standing across the room from you, the light bouncing off their face took a few nanoseconds to reach your eyes. Technically, you've never seen anyone in the present. We are all ghosts to each other, images from moments that have already passed. According to Einstein's theory of relativity, confirmed by countless experiments over the past century, there is no universal now. Time is relative, bending and stretching depending on speed and gravity. What you call this moment is different from what an astronaut calls this moment on the International Space Station. Their clocks run slightly faster than ours because they're farther from Earth's gravitational pull. It's not an illusion or a trick of measurement. It's the actual fabric of space-time behaving differently in different conditions. NASA's atomic clocks have measured this effect with extraordinary precision. When synchronized clocks are separated, one flown on a jet and one left on the ground, they fall out of sync by exactly the amount Einstein's equations predict. Time truly does pass at different rates depending on where you are and how fast you're moving. This means the universe has no single timeline, no cosmic clock ticking the same seconds everywhere. Instead, space-time is a patchwork of perspectives, each observer experiencing their own version of now. When you look at a star 100 light-years away, you see it as it was a century ago. But from the star's perspective, in its own reference frame, it exists now just as you do. The catch? That star's now doesn't overlap with yours. You exist in each other's past and future simultaneously, separated not by distance alone but by the architecture of space-time itself. The European Space Agency's Gaia satellite has mapped over 1.8 billion stars in our galaxy with stunning accuracy, measuring their positions, movements, and distances. And what this data reveals is humbling. Every star we see is a time capsule. The Milky Way isn't just a collection of suns, it's a museum of moments, each light beam carrying news from a different era. Some of those stars no longer exist. They exploded as supernovae centuries ago, but their light is still traveling toward us, and we won't know they're gone until their final photons arrive. Think about that for a moment. Right now, scattered across space, there are beams of light heading toward Earth that will tell us about stars dying tonight, stars being born in nurseries of gas and dust, stars colliding in violent mergers. But we won't receive that information for hundreds or thousands or millions of years. The universe is constantly sending us messages, and we're always reading yesterday's mail. Carl Sagan once said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." But he might have added this: "We are also a way for the universe to remember itself, one delayed photon at a time." Because every time we look up, we're not just seeing space. We're seeing time made visible, history written in light. And in that light, we find something extraordinary. The past is not gone. It's still traveling, still moving through the dark, still arriving. When we think of time, we imagine it flowing like a river, carrying us from past to future. But Einstein showed us something different. Time is more like a landscape, a vast terrain where past, present, and future exist simultaneously, separated not by when, but by where you stand. This is called the block universe model, and it suggests that every moment that has ever happened or ever will happen already exists, frozen in the four-dimensional fabric of space-time. From this view, your birth, your childhood, this very moment, and the moment of your last breath are all equally real, just located at different coordinates in time. It's a challenging idea. It feels wrong because our experience is so linear, so locked into the sensation of now flowing forward. But physics doesn't care about our feelings. It describes what is, not what seems. Astronomer Michelle Thaler of NASA often speaks about how humbling it is to realize we live in a universe where causality has a speed limit. Nothing, not even information, can travel faster than light. And because of this, the universe enforces a kind of cosmic patience. You cannot know what's happening on Alpha Centauri, our nearest star system, until 4.37 years have passed. You cannot affect it either. If you sent a message today, it wouldn't arrive until over 4 years from now, and you wouldn't hear back for another 4 years after that. This speed limit is woven into the structure of reality itself, and it means that the universe is, in a very real sense, made of delays, of waiting, of light moving through darkness. Now, here's where it gets strange. If the speed of light is the universe's speed limit, and if we can never see or know the present moment of anything distant, then what does that say about reality itself? Is there even such a thing as a universal present? Or is the present just a local phenomenon, a bubble of experience unique to your position in space-time? Physicists have debated this for over a century. Some, like Einstein, accepted that simultaneity, the idea of two events happening at the same time, is purely relative. Others, seeking a deeper framework, have proposed hidden structures, quantum fields, or informational substrates that might restore some form of absolute time. But so far, no experiment has contradicted relativity. ESA's Planck satellite measured the cosmic microwave background, the faint afterglow of the Big Bang, with unprecedented precision. This light has been traveling for 13.8 billion years, and when we study it, we're looking at the universe when it was just 380,000 years old. At that time, space was filled with a hot, dense plasma of particles and radiation. As the universe expanded and cooled, that plasma became transparent, and light was finally free to travel. That light, stretched and redshifted by billions of years of expansion, reaches us now as microwaves. It's the oldest light in the universe, and it shows us something astonishing. The early universe was remarkably uniform, smooth and nearly featureless, with only tiny fluctuations in temperature and density. Those fluctuations, mere ripples in space-time, eventually grew into galaxies, stars, and planets, into us. But here's what moves me most. When we look at that ancient light, we're not just seeing the past, we're seeing the seeds of everything. Every structure in the modern universe, from the smallest grain of sand to the largest supercluster of galaxies, began as a quantum fluctuation in the first fractions of a second after the Big Bang. Those fluctuations were stretched across space by a process called inflation, a brief but explosive expansion that happened faster than the speed of light. And yes, that's allowed. Space itself can expand faster than light because it's not moving through space. It's the expansion of space. The speed limit only applies to things moving within space. NASA's Hubble Space Telescope and its successor, the James Webb Space Telescope, have allowed us to see deeper into time than ever before. JWST, launched in December 2021, observes infrared light, which lets it peer through cosmic dust and detect the faintest, most distant galaxies. In 2023, it spotted galaxies that formed just 300 million years after the Big Bang. These galaxies are so far away that their light has been traveling for over 13 billion years, and because the universe has been expanding that entire time, those galaxies are now more than 30 billion light-years away. We see them where they were, not where they are. Distance and time collapse into one strange, layered reality. What fascinates me is the implication for memory. If the past still exists out there in the light, traveling toward us, then in a sense, nothing is ever truly lost. Every moment is preserved in the pattern of photons spreading outward through space. If you could somehow travel faster than light, which you can't, but if you could chase down the light from any moment in history and watch it unfold again. You could see dinosaurs walking the earth, watch the first humans paint on cave walls, witness your own birth. The light from those moments is still out there, moving farther and farther into the cosmos. This means the universe is not just a place, it's an archive. Every event that has ever occurred is stored in light, scattered across space like pages of a book written in photons. And we, standing here on this small blue world, are readers flipping through those pages one glimpse at a time. We can never read the whole book because the universe is too vast and light takes too long to arrive. But we can read fragments. We can piece together the story of where we came from, how stars were born, how galaxies formed, how the conditions for life emerged. Neil deGrasse Tyson once said, "We are part of this universe. We are in this universe. But perhaps more important than both of those facts, the universe is in us." He was talking about the fact that the atoms in our bodies were forged in the hearts of ancient stars, scattered into space when those stars died, and eventually coalesced into planets and people. But his words also apply to time. The universe's history is in us, encoded in every atom, every molecule, every strand of DNA. We are not separate from the cosmic story. We are a chapter in it. And yet, even as we reach back through time with our telescopes, peering into the universe's infancy, there remains one horizon we cannot cross, a boundary beyond which no light can reach us. It's called the cosmic event horizon, and it marks the limit of the observable universe. Because space is expanding, and because that expansion is accelerating, there are regions of space moving away from us faster than light can travel. Light from those regions will never reach us, not because it's too faint, but because space itself is stretching faster than the light can cross it. This means there are galaxies, stars, perhaps even other civilizations that we will never see, never know, never detect. They exist, but they are forever beyond our reach. The accelerating expansion of the universe was discovered in 1998 by two independent teams of astronomers studying distant supernovae. They expected to find that gravity was slowing the expansion, pulling galaxies back together. Instead, they found the opposite. The expansion is speeding up, driven by something called dark energy, a mysterious force that makes up about 68% of the universe's total energy content. We don't know what dark energy is. We can only measure its effects, and those effects are profound. They mean that over billions of years, the universe will become lonelier. Distant galaxies will accelerate away from us, their light redshifting into invisibility. Eventually, trillions of years from now, all galaxies outside our local group will disappear from view. The night sky will go dark, and future astronomers, if they exist, will see only the stars of their own galaxy. They won't know about the Big Bang, the cosmic microwave background, or the vast web of galaxies that fills the universe today. All that history will be hidden beyond the horizon, lost not because it was destroyed, but because space stretched too far. This idea that future beings might never know the full story of the universe because the evidence will have faded is humbling and a little heartbreaking. It reminds us that our place in cosmic history is special. We live in an era when the universe is still young enough, still visible enough, for us to piece together its origins. We are witnesses to a story that won't always be visible. And in that sense, we carry a kind of responsibility, not to the universe itself, which doesn't care whether we understand it, but to ourselves, to the curiosity that makes us human. When I think about time and light and memory, I think about photographs. A photograph captures a moment, freezing it in place so that even after the moment has passed, you can return to it. The universe does something similar. Every beam of light is a photograph, a frozen instant traveling through space. When you look at a star, you're seeing a photograph taken years ago, and the star itself is the camera. Your eyes are the screen on which the image appears, delayed by however long it took the light to travel. We live inside an enormous, slow-motion gallery, surrounded by images from the past. And every time we point a telescope at the sky, we're curating that gallery, choosing which moments to examine, which pieces of history to bring into focus. But here's the twist. While we're looking back in time, something else is happening. Right now, light from Earth is traveling outward into space. In 8.6 years, that light will pass Sirius. In 548 years, it will reach Betelgeuse. In 2.5 million years, it will arrive at Andromeda, our nearest major galaxy. And if anyone is out there looking back, they won't see us as we are now. They'll see Earth as it was when that light left, years or centuries or millennia ago. To them, we are the past. Just as distant stars are the past to us. This creates a strange symmetry. Everyone in the universe is seeing everyone else in the past. There is no universal now, only a web of delayed images crisscrossing the cosmos, each observer caught in their own bubble of time. Einstein called this the relativity of simultaneity, and it's one of the deepest insights of modern physics. It means that when we ask, what's happening right now on a planet orbiting a star 1,000 light-years away, the question has no single answer. It depends on your frame of reference, your motion, your position in space-time. Two observers moving at different speeds will disagree about which events are simultaneous, and both will be correct within their own frames of reference. Time is not a universal river. It's a private experience, shaped by where you are and how you're moving. This has profound implications for how we think about existence. If the present moment is not universal, then the past and future are not fixed categories either. They shift depending on perspective. An event that's in your past might still be in someone else's future, depending on where they are and how they're moving. Space-time is not a stage where events happen. It's a fabric woven from events themselves, each one connected to others by threads of causality, light cones spreading outward at the speed of light. Inside your light cone is everything that could have influenced you or that you could influence. Outside it is everything beyond your reach, separated not by distance alone, but by the structure of space-time itself. The mathematician Hermann Minkowski, who was Einstein's teacher, was the first to fully articulate this view. In 1908, he declared, "Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." He was describing what we now call space-time, a four-dimensional continuum where space and time are inseparable. You can't move through space without moving through time, and you can't move through time without moving through space. The two are woven together, and the geometry of space-time determines how matter and energy behave, how light travels, how gravity pulls. This is the foundation of general relativity, and it has been tested and confirmed in countless experiments, from the bending of starlight around the sun to the detection of gravitational waves from colliding black holes. But even as we marvel at the accuracy of Einstein's equations, there's something unsettling about the picture they paint. If time is just another dimension, like length or width, then in what sense are we moving through it? Why does it feel like time flows when physics suggests it's just a static landscape? This is called the problem of the arrow of time, and it's one of the great unsolved mysteries in physics. Why do we remember the past but not the future? Why does cause always precede effect? Why does entropy, the measure of disorder, always increase, never decrease? The laws of physics themselves are mostly time-symmetric. They work just as well running forward or backward. And yet, the universe clearly has a direction. Eggs break but don't unbreak. Stars burn but don't unburn. Life grows, ages, and dies, never the reverse. The answer, most physicists believe, lies in the Big Bang. The early universe was in an extraordinarily low entropy state, highly ordered and uniform. As it expanded and cooled, entropy increased, and that increase defines the arrow of time. We move from past to future because we move from low entropy to high entropy. Memory works because our brains are thermodynamic systems that record information by increasing entropy. We can't remember the future because the future hasn't been thermodynamically encoded yet. The second law of thermodynamics, which states that entropy always increases, is what gives time its direction. It's what makes the future different from the past. But this raises another question. Why was the early universe in such a low entropy state to begin with? Why did the Big Bang start the clock of entropy? Some cosmologists speculate that our universe might be part of a larger multiverse, where different regions have different initial conditions, different arrows of time. In some regions, time might flow backward, or not flow at all. We find ourselves in a region where entropy increases because those are the only regions where conscious observers can exist. It's a form of the anthropic principle, the idea that the universe appears fine-tuned for life, because, if it weren't, we wouldn't be here to ask the question. ESA's Euclid telescope, launched in 2023, is designed to map the large-scale structure of the universe and study the nature of dark energy and dark matter. By observing billions of galaxies across cosmic time, it will help us understand how the universe has evolved, how structure has formed, and how the arrow of time manifests on the largest scales. What we see in these surveys is consistent with a universe expanding from a low entropy beginning, growing more disordered over time, heading toward a distant future where all stars have burned out, all black holes have evaporated, and nothing remains but cold, diffuse particles drifting through empty space. This is called the heat death of the universe, and it's the ultimate fate predicted by thermodynamics. But let's not dwell in endings just yet. We have billions of years before that future arrives, and in the meantime, we live in a universe still rich with structure, still filled with stars and galaxies, still capable of producing complexity and beauty. And part of that beauty is the way time and memory intertwine. When we look at ancient light, we're not just seeing images from the past. We're connecting across time, reaching back to touch moments that happened long before we existed. And in doing so, we're participating in something extraordinary. We're closing the loop. The universe created the conditions for stars, stars created the elements, elements created planets, planets created life, and life created minds capable of looking back and understanding where it all came from. In that sense, we are the universe becoming self-aware, the cosmos opening its eyes and seeing itself for the first time. Every observation we make, every measurement, every photograph from a telescope is the universe studying its own history. And because we are made of star stuff, as Sagan said, we are not outside the story. We are inside it, woven into the same fabric of spacetime that holds galaxies and light and memory. When you look at a star, you're seeing light that left its surface years ago. But you're also seeing proof of connection. That star and you are part of the same cosmic web, linked by photons, by time, by the shared history of matter and energy evolving over billions of years. This is why astronomy feels different from other sciences. It's not just about discovering facts, it's about witnessing. Every time you gaze at the night sky, you're standing at the intersection of past and present, seeing ghosts of stars that might no longer exist, receiving messages sent long before you were born, and in return, you send your own light outward, your own electromagnetic signature radiating into space at the speed of light, carrying the imprint of this moment into the future. Someday, trillions of years from now, long after Earth is gone, that light will still be traveling, a faint echo of humanity moving through the dark. There's a poignant thought experiment that illustrates this beautifully. Imagine an alien civilization 65 million light-years away with a telescope powerful enough to see Earth's surface. Right now, they would be seeing dinosaurs. The light from that era is only just reaching them. If they've been watching for the past 65 million years, they've seen the asteroid impact, the extinction, the rise of mammals, the evolution of primates, the appearance of humans, but they're watching it on a 5 million year delay. To them, we don't exist yet. We are in their future. And if they send a message to us today, we won't receive it for 65 million years. By then, who knows what Earth will look like? Humanity might be long gone, replaced by something else, or nothing at all. The message will arrive in an empty solar system, a signal from a distant past to an uncertain future. This is the nature of communication across cosmic distances. It's slow, patient, and uncertain, but it's also profoundly hopeful, because every signal we send, every radio wave, every laser pulse is a message in a bottle, cast into the ocean of space, hoping to reach someone, somewhere, someday. And every signal we receive, every photon from a distant star, is proof that the universe wants to be known. It's sending us its story, one particle of light at a time. Now, as we drift deeper into this meditation on time and light, let's turn our attention to something more intimate, not the distant stars or ancient galaxies, but the light that surrounds us here and now. The light in this room, the glow of your screen, the faint shimmer of the moon if you happen to glance outside. All of it carries the same strange properties, the same delays, the same connections to the past. Because light doesn't care about scale. Whether it's traveled billions of light years or just a few feet, it follows the same rules. And those rules tell us something extraordinary. The present moment is always just out of reach. What we see is always a memory, and memory is the only reality we ever know. Let's think about the light from your screen right now. The photons hitting your eyes were created just nanoseconds ago, a billionth of a second, by the electronic circuits inside your device. They traveled through the liquid crystal display, through the air, and finally into your retina, where they triggered a cascade of chemical reactions that sent signals to your brain. By the time your brain processed those signals and constructed an image, even more time had passed. So, even the most immediate, most present thing you can see, this screen, these words, is not happening now. It's happening in the recent past, delayed by the speed of light and the processing time of your neurons. This delay is so small that it feels irrelevant. But it's not, it's fundamental. It means that perception itself is a form of memory. You have never experienced the world in real time, not once. Everything you see, hear, touch, taste, or smell is delayed, filtered through the speed of neurons and the laws of physics. Your senses are not windows to the present, they're archives of the immediate past. And your sense of now, that feeling of existing in this moment, is an illusion created by your brain to stitch together all those delayed signals into a coherent experience. Neuroscientists have long known that the brain doesn't process sensory information instantly. There's a lag, typically around 80 to 100 milliseconds, between when something happens and when you become consciously aware of it. This is called the neural delay, and it's been measured in countless experiments. For example, if someone touches your toe and your nose at the same time, your brain receives the signal from your nose first because it has less distance to travel through your nervous system. But your brain compensates. It holds the signal from your nose and waits for the signal from your toe to arrive. then presents both sensations to your consciousness as if they happened simultaneously. Your brain is constantly editing reality, smoothing out the delays, creating the illusion of a unified present moment. This has led some philosophers and scientists to argue that free will might be an illusion. If your brain is making decisions before you're consciously aware of them, which studies have shown it does, then in what sense are you choosing? Are you the author of your actions, or are you just witnessing them after they've already begun? It's a troubling question, and there's no easy answer, but it ties into the larger mystery of time. If the present moment is always delayed, always constructed, always interpreted, then what does it mean to exist in time? Are we passengers in a universe that's already written, or are we active participants shaping the future? Physics suggests something in between. On the quantum level, the future is not determined. Particles exist in superpositions, multiple states at once, until they're observed or interact with something else. At that moment, they collapse into a single state, and the future becomes fixed. This is the measurement problem in quantum mechanics, and it's one of the most debated topics in all of science. Some interpretations, like the Copenhagen interpretation, say that observation creates reality. Others, like the many worlds interpretation, say that every possible outcome happens, each in its own branch of reality. And still others, like pilot wave theory, suggest there's a deeper layer of hidden variables we haven't discovered yet. What all these interpretations agree on is that the future is not entirely fixed. On the smallest scales, there's genuine randomness, genuine uncertainty, and as those quantum events cascade upward, influencing atoms, molecules, cells, and brains, they introduce unpredictability into the universe. So even though the past might be written in light, traveling through space as a permanent record, the future is still being written. Every moment, quantum events are branching, creating new possibilities, new paths through spacetime. And we, with our choices and actions, however constrained by physics and biology, are part of that creative process. This brings us to a question that has fascinated thinkers for centuries. If we are made of atoms that obey physical laws, if our thoughts are just electrical signals in neurons, if our decisions are influenced by genetics and environment and quantum randomness, then in what sense are we free? And in what sense are we responsible for our actions? It's the age-old debate between determinism and free will, and modern physics hasn't resolved it. If anything, it's made it more complex. But here's a perspective that brings me comfort. Even if the universe is deterministic on some level, even if every particle is following a set of rules, that doesn't mean the future is predictable. Chaos theory, developed in the 1960 seconds and 70 seconds, shows that even simple deterministic systems can be wildly unpredictable. The famous example is the butterfly effect. The idea that a butterfly flapping its wings in Brazil could set off a chain of events that leads to a tornado in Texas. It's not that the butterfly causes the tornado in any direct sense. It's that small changes in initial conditions can lead to vastly different outcomes in complex systems. Weather, ecosystems, economies, human societies, all of these are chaotic systems where prediction becomes impossible beyond a certain point. So even if the laws of physics are deterministic, the universe is still open, still surprising, still capable of novelty. And that openness is where meaning lives. It's where choice, however constrained, still matters. Every action you take sends ripples through the world, influencing events in ways you can't fully predict or control. And those ripples, like light from a distant star, travel outward, affecting others, creating new possibilities. In that sense, you are not just a witness to the universe. You are a participant, a creator, a small but real force shaping what comes next. When I think about this, I feel a sense of awe and humility. We are such tiny beings, living on a small planet orbiting an average star in a vast galaxy that's just one of trillions. Our lives are brief, a mere blink in cosmic time. And yet, we matter. Not because the universe cares about us, it doesn't, but because we care. Because we have the capacity to see beauty, to ask questions, to feel wonder, to love. That capacity, however it arose, is real, and it gives our existence weight, significance, meaning, even if that meaning is not written into the fabric of the cosmos but emerges from within us. The physicist Sean Carroll once said, "We are not the reason the universe exists, but we are the reason the universe has meaning." I think he's right. Meaning is not something we discover out there among the stars. It's something we create here, in our lives, in our relationships, in our efforts to understand and connect. And one of the most profound ways we create meaning is by reaching back through time, by learning the story of where we came from, by seeing ourselves as part of a cosmic narrative that stretches from the Big Bang to this very moment. Now, as we continue this journey, let's consider an even stranger aspect of light and time. We've talked about how light allows us to see the past, but there's another side to this story. Light doesn't just carry information about the past, it also connects us to it in a very real, physical way. Every photon that enters your eye, every particle of light, is a tiny messenger from somewhere else in space-time. And because photons have no mass, they don't experience time at all. From a photon's perspective, if it could have one, the moment it's emitted and the moment it's absorbed are the same instant. It doesn't age, it doesn't decay. It exists in a kind of eternal now, even as it travels for billions of years through space. This is one of the strangest consequences of relativity. At the speed of light, time stops. If you could ride a photon, which you can't, you would experience no passage of time. You would be emitted from a star and absorbed by an eye in the same instant, even if billions of years passed in the external universe. This means that, in a sense, every photon is a direct connection between two events in space-time, a bridge that collapses time to zero. When you look at a star, you're not just seeing it as it was. You're touching it, in a sense, receiving a piece of it that has traveled through the void to reach you. This idea that light connects distant moments in space-time is at the heart of why astronomy feels so intimate. It's not just abstract science, it's personal. Every time you see a star, you're connected to it. A photon left that star's surface, journeyed through the dark, and ended in your eye, completing a transaction that began long ago and ends with you. You are the destination, the final chapter of that photon story. And in that way, you are not separate from the cosmos. You are part of its flow, its continuity, its endless exchange of energy and information. Now, let's take this a step further. If every moment is preserved in light traveling outward, and if that light can, in principle, reach any part of the universe, given enough time, then the universe is not just an archive, it's a living memory, constantly recording itself, constantly sending signals back and forth across space-time. Every event, no matter how small, leaves a trace, and those traces, though faint, are never truly erased. They're just spread out, diluted, transformed, but not lost. This idea has profound implications for how we think about existence. If nothing is ever truly lost, if every moment is preserved in the light it emits, then the past is not gone. It's still here, woven into the fabric of the universe. It's in the light traveling through space, in the gravitational waves rippling outward from colliding black holes, in the faint cosmic microwave background radiation that fills the sky. The past surrounds us, always, invisible but real. And we, by observing it, by studying it, by remembering it, bring it back into the present. This is what memory is, not just for individuals but for the universe itself. Memory is the persistence of information, the way the past continues to influence the present. In our brains, memory is stored in the connections between neurons, in the patterns of synapses that fire when we recall something. In the universe, memory is stored in the patterns of light, gravity, and matter. In the structure of galaxies, the chemistry of stars, the fossils in rocks, the genetic code in our DNA. Every layer of reality carries the imprint of what came before, and by studying those layers, we can reconstruct the story of the cosmos, piece by piece, moment by moment. The James Webb Space Telescope is doing exactly this. By observing the most distant galaxies, it's peering back to a time when the universe was less than 1 billion years old. These galaxies are not only far away in space, they're far away in time, and what JWST sees in them is shocking. These early galaxies are brighter, more massive, and more structured than our models predicted. They challenge our understanding of how galaxies form and evolve. And that's exactly what science is about. Not confirming what we already believe, but confronting what surprises us, what contradicts our expectations, what forces us to rethink. ESA's upcoming aerial telescope, set to launch in 2029, will focus on exoplanet atmospheres, analyzing the chemical composition of planets orbiting other stars. By studying the light that passes through these atmospheres, scientists can detect water vapor, methane, carbon dioxide, and other molecules. Each spectrum is like a fingerprint, unique to each planet. And in those fingerprints, we might find signs of life. Not definitive proof, but hints, possibilities, clues that we are not alone. Because if there's one thing the universe has taught us, it's that wherever conditions allow, complexity emerges. Stars form, planets coalesce, chemistry becomes biochemistry, and biochemistry, under the right circumstances, becomes life. We don't know if life is common or rare. We have a sample size of 1, Earth, but we do know that the ingredients for life, carbon, hydrogen, oxygen, nitrogen, are abundant throughout the universe. And we know that planets are common too. NASA's Kepler mission discovered that most stars have planets, and many of those planets are in the habitable zone, the region where liquid water could exist. That doesn't mean they have life, but it means they could. And if even a tiny fraction of those planets do harbor life, then the universe is teeming with it. We are not alone. We are part of a vast community, separated by distance and time, but connected by the same chemistry, the same physics, the same cosmic origin. This is why the search for extraterrestrial intelligence, SETI, is so important. Not because we expect to find messages from aliens tomorrow, but because the question itself, are we alone, is one of the most profound questions humanity has ever asked. It touches on our place in the universe, our significance, our future. If we find life elsewhere, even microbial life, it will change everything. It will tell us that life is not a fluke, not a cosmic accident, but a natural outcome of the laws of physics. And if we find intelligent life, beings capable of building civilizations, creating art, asking questions, then we'll know something even more extraordinary. That consciousness, whatever it is not unique to Earth. That the universe is not just filled with matter and energy, it's filled with minds. But even if we never find alien life, even if we're alone in the observable universe, that doesn't diminish our importance. If anything, it magnifies it. Because if we are the only conscious beings, the only ones who can understand the cosmos, appreciate its beauty, mourn its losses, celebrate its wonders, then we carry a unique responsibility. We are the universe's only witnesses, the only ones who can tell its story. And that story, the story of how matter became life, how life became consciousness, how consciousness became capable of looking back and understanding its own origins, that story is ours to tell. Carl Sagan understood this deeply. In his series Cosmos, he said, "We are a way for the universe to know itself. Some part of our being knows this is where we came from. We long to return." And we can, because the cosmos is also within us. We are made of star stuff. Those words resonate because they're true, not metaphorically, but literally. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in the cores of ancient stars. When those stars died, they scattered those elements into space, seeding the next generation of stars and planets. One of those planets was Earth. And on Earth, Those elements came together in just the right way to create life, and eventually, life became us. So when you look up at the stars, remember this. You're not looking at something separate, something distant and foreign. You're looking at your ancestors. Those stars made you. And in a very real sense, you are the universe waking up, looking at itself, and realizing, for the first time, what it is. Now, as we near the end of this long, quiet journey through time and space, I want to leave you with a final thought, a meditation on the nature of now. We've talked about how the present moment is always delayed, always out of reach, always a memory. But maybe that's not something to mourn. Maybe that's the beauty of it. Because if the present is always slipping into the past, then every moment is precious. Every breath, every heartbeat, every glance at the stars is fleeting, unrepeatable, unique. You will never stand exactly here, in this moment, again. The light you see tonight will be different tomorrow. The stars will have moved, however slightly. The universe will have expanded. And you will have changed too. Time is not a prison, it's a gift. It's what makes life possible, what makes growth possible, what makes change possible. Without time, there would be no stories, no journeys, no discoveries. Everything would be static, frozen, eternal. And while eternity sounds peaceful, it's also lifeless. Time is the engine of existence. It's what turns potential into reality, what transforms the possible into the actual. And every moment you experience is part of that transformation, part of the ongoing creation of the universe. So, as you lie down tonight, as your breathing slows and your thoughts begin to drift, remember this. You are not separate from the cosmos. You are part of it. Every atom in your body, every thought in your mind, every emotion in your heart is woven into the same fabric that holds galaxies, together. You are made of time and light and memory. And when you close your eyes and let yourself fall into sleep, you're not leaving the universe behind. You're sinking deeper into it, joining the slow rhythm of stars and planets, the ancient dance of matter and energy. The past is not gone. It's still traveling, still moving through the dark, still arriving in beams of light from distant suns, and the future is not yet written. It's being shaped right now, by quantum events too small to see, by choices too complex to predict, by the slow unfolding of entropy and time. You are part of that shaping. Your life, however brief, leaves a mark, a ripple in spacetime, a pattern in the flow of energy, a story told in atoms and light. And one day, long after you're gone, your atoms will return to the cosmos. They'll be scattered by wind and water, by decay and dissolution, and eventually, they'll become part of something else. A tree, perhaps, or a river, or a distant star. The elements that make you will travel through space and time, carrying the faint echo of your existence forward into the future. You will become star stuff again, joining the endless cycle of creation and destruction that has been unfolding for 13.8 billion years. But right now, in this moment, you are here, conscious, aware, capable of wonder. And that is the greatest miracle of all. Not that the universe is vast, but that it produced something small enough to see it. Not that time is infinite, but that it gave rise to beings who can measure it. Not that existence is possible, but that it became aware of itself. So take a slow, deep breath. Feel the air enter your lungs, oxygen molecules forged in dying stars. Feel your heartbeat, a rhythm as old as life itself. Feel the weight of your body, atoms held together by forces that emerged in the first moments of the Big Bang. You are a living archive of cosmic history, a walking, breathing, thinking piece of the universe. And when you look up at the tiniest night sky, know that you are not gazing at something foreign, you are looking at home. The stars you see tonight are not ghosts, they are messengers, and their message is simple. You are part of this. You always have been, and you always will be. The light that touches your eyes tonight began its journey long ago, perhaps before you were born, and the light you emit The faint infrared glow of your body's warmth, the reflection of light from your skin, is traveling outward now, into the dark, carrying the trace of this moment into the future. Someday, trillions of years from now, that light will still be moving. A faint echo of you, a photon that left your body on this quiet night, still traveling, still carrying information, still connecting this moment to some distant future we can't imagine. And in that sense, you are eternal. Not because your consciousness survives, we don't know if it does, but because your existence leaves a mark. A physical, measurable, permanent mark on the structure of space-time. You were here, you mattered, and the universe will never be quite the same because of you. So as you drift into sleep, as your thoughts dissolve into dreams, know that you are held by something larger than yourself, not by fate or destiny or divine plan, but by the simple, beautiful fact that you are part of the cosmos. You are woven into its fabric. You are a thread in its tapestry. And when the universe looks at itself, it sees through your eyes. When it wonders with your mind. When it loves with your heart. You are the universe, awake. And tonight, as the stars turn slowly overhead, as light from ancient suns falls gently through the darkness, remember this. The cosmos is not out there. It's in here. It's in you. And it always has been. Rest well, traveler. The universe is holding you, and it will still be here when you wake. Now, as we continue deeper into this meditation, let's explore something that might seem impossible at first, a question that has puzzled scientists and philosophers for generations. If we are made of the universe, if our atoms came from stars, if our consciousness emerged from matter, then what does that say about the nature of reality itself? Are we observers of the universe, or are we the universe observing itself? And if it's the latter, then what happens when we dream? Think about it. When you close your eyes at night and drift into sleep, your brain doesn't stop working. It continues to process, to create, to imagine. Dreams are strange, aren't they? They feel real while they're happening, sometimes more real than waking life. Colors seem brighter, emotions feel deeper, and the laws of physics bend and break in ways that seem perfectly natural until you wake up. You can fly in dreams. You can breathe underwater. You can visit places that don't exist and talk to people who have long since passed away. Time becomes fluid, stretching and compressing. A dream that feels like hours might last only minutes. A lifetime can pass in a single night. Neuroscientists have studied dreams extensively, mapping the brain activity that occurs during REM sleep, the stage where most vivid dreams happen. During REM, the visual cortex lights up as brightly as it does when you're awake and seeing real things. The emotional centers of your brain become hyperactive, which is why dreams can be so intensely joyful or terrifying. But the prefrontal cortex, the part responsible for logical thinking and reality testing, quiets down. This is why dreams feel real while they're happening. Your brain has temporarily suspended its ability to question whether what you're experiencing makes sense. But here's what fascinates me. While you're dreaming, your brain is creating an entire reality from scratch. It's generating landscapes, people, conversations, sensations, all without any external input. The photons hitting your closed eyelids aren't creating images. Your ears aren't hearing actual sounds. Your body isn't feeling actual touch. And yet, in the dream, you see, hear, and feel everything. Your brain is constructing a complete sensory experience using only memory, emotion, and the random firing of neurons. In that sense, a dream is a private universe, a reality that exists only for you, only for the duration of the dream. This raises a profound question. If your brain can create an entire convincing reality while you sleep, how do you know it's not doing the same thing while you're awake? How do you know that what you call reality isn't just another dream, another construction of your brain? Philosophers have wrestled with this for millennia. The ancient Chinese philosopher Zhuangzi told a famous story about dreaming he was a butterfly. When he woke up, he couldn't be sure whether he was Zhuangzi who had dreamed of being a butterfly, or a butterfly now dreaming he was Zhuangzi. How do we distinguish between waking and dreaming? How do we know which state is real? The answer, from a neuroscience perspective, is that both states are real. They're just different kinds of reality. When you're awake, your brain is processing external sensory data and constructing a model of the world based on that data. When you're dreaming, your brain is processing internal data, memories, emotions, random neural activity, and constructing a model based on that. In both cases, what you experience is not the world itself, but your brain's interpretation of signals. Reality, as you perceive it, is always mediated, always filtered, always constructed. You never have direct access to the objective world. You only have access to your brain's representation of it. This idea, that perception is construction, has been confirmed by decades of research. The brain doesn't passively receive information like a camera. It actively predicts what it expects to see, hear, and feel, and then compares those predictions to incoming sensory data. When the data matches the prediction, you experience smooth, effortless perception. When there's a mismatch, your brain updates its model. This is called predictive processing, and it's one of the leading theories of how consciousness works. Your experience of reality is essentially your brain's best guess about what's happening, constantly updated and refined. This has strange implications. It means that two people can look at the same thing and see it differently, not just in terms of interpretation, but in terms of actual perception. Studies have shown that what you expect to see influences what you do see. If you're told that a wine is expensive, you'll rate it as tasting better than if you're told it's cheap, even if it's the same wine. If you're shown a blurry image and told it's a face, you'll see a face. If you're told it's a landscape, you'll see a landscape. Your brain fills in missing information based on context, expectation, and prior experience. And here's where it connects back to the cosmos. Just as your brain constructs your personal reality, the universe itself might be constructing something larger. Some physicists and philosophers have proposed that consciousness is not just a byproduct of complex brains, but a fundamental feature of reality itself. This idea, called panpsychism, suggests that even the simplest particles have some rudimentary form of experience, some proto-consciousness that becomes more complex as matter organizes into more complex structures. According to this view, electrons and quarks don't have thoughts or feelings, but they have some basic inner aspect, some subjectivity that combines and integrates as atoms form molecules, molecules form cells, and cells form brains. This might sound like mysticism, but it's actually rooted in a real problem in philosophy of mind. The hard problem of consciousness, as philosopher David Chalmers calls it, is the question of why physical processes in the brain give rise to subjective experience. Why does it feel like something to be you? Why is there an inner life, a stream of thoughts and sensations associated with the firing of neurons? Science can explain what the brain does, how neurons communicate, how information is processed, but it can't yet explain why any of that should produce the feeling of being conscious. Panpsychism offers one possible answer. If consciousness is fundamental, if it's built into the fabric of reality at the most basic level, then the emergence of human consciousness isn't a miracle. It's just matter organizing itself in increasingly complex ways, amplifying and integrating the consciousness that was always there. Whether or not panpsychism is true, and most scientists are skeptical, it points to something important. Consciousness is deeply mysterious, and that mystery connects us back to the stars, to the question of whether we're alone in the universe. Because if consciousness emerged once, here on Earth, from the interaction of matter and energy, then it could emerge elsewhere too. And if it has, then somewhere out there, under alien skies, other beings might be looking up and wondering the same things we are. Are we alone? What is our purpose? Why does the universe exist? NASA's Kepler Space Telescope during its mission from 2009 to 2018, discovered over 2,600 confirmed exoplanets and thousands more candidates. These planets vary wildly. Some are gas giants larger than Jupiter, others are rocky worlds smaller than Earth. Some orbit close to their stars, baked by intense heat. Others orbit far away, frozen and dark. But a significant number fall into what's called the habitable zone, the region around a star where temperatures allow liquid water to exist on a planet's surface. Water is essential for life as we know it. It's a solvent, a medium for chemistry, a regulator of temperature. Every living thing on Earth depends on it. The discovery of so many potentially habitable planets has transformed the question of extraterrestrial life from philosophy to science. We now know that the raw materials are there. The question is whether life actually arose, and if it did, whether it evolved into complex, intelligent forms. The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to estimate the number of communicating civilizations in our galaxy. It takes into account factors like the rate of star formation, the fraction of stars with planets, the number of habitable planets per star system, the probability that life develops, the probability that life becomes intelligent, and the length of time civilizations remain detectable. The problem is that most of these factors are unknown. We can make educated guesses, but the range of possibilities is enormous. There could be millions of civilizations in the Milky Way, or we could be the only one. The Fermi paradox captures this tension. If the universe is so vast, if there are so many potentially habitable planets, then where is everyone? Why haven't we detected any signals, any evidence of alien technology? Enrico Fermi, the physicist who first posed this question, was troubled by the silence. And there are many possible explanations. Maybe intelligent life is extremely rare. Maybe civilizations destroy themselves before they develop interstellar communication. Maybe they exist but are too far away for us to detect. Maybe they're deliberately hiding, or maybe they're all around us, and we just don't recognize the signs because we're looking for the wrong things. One possibility that I find both beautiful and unsettling is the zoo hypothesis. It suggests that advanced civilizations know we're here, but are deliberately not contacting us, observing us from afar, like researchers studying animals in the wild. They're waiting for us to reach a certain level of maturity, a threshold of development, before they reveal themselves. It's speculative, of course, but it raises the question of what that threshold might be. Is it technological? Will we be welcomed into it? The galactic community, once we achieve faster than light travel or harness the energy of our sun, or is it ethical? Will we be contacted only when we've overcome war, inequality, and environmental destruction? When we've proven we can be trusted with the power that comes with advanced knowledge? These are the kinds of questions that make me stay up at night, staring at the ceiling, turning thoughts over in my mind, because they're not just about aliens, they're about us. About who we are, who we want to become, what kind of species we're capable of being. Every time we send a spacecraft into the void, every time we broadcast a radio message into space, we're making a statement. We're saying, we're here, we're curious, we want to know. And in doing so, we're shaping not just our own future, but potentially the future of the entire cosmos. The Voyager probes, launched in 1977, are now beyond the edge of our solar system, traveling through interstellar space. Each carries a golden record, a disc containing sounds and images from Earth, music from different cultures, greetings in 55 languages, photographs of people, animals, landscapes. It's a message in a bottle, cast into the cosmic ocean. The chances of it being found are infinitesimally small. Space is vast and the probes are tiny. But that's not really the point. The golden record is as much for us as it is for any potential alien discoverers. It's a statement of hope, a gesture of connection, a reminder that we are part of something larger. Carl Sagan, who helped design the golden record, said, "The spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space." But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. He understood that the act of reaching out, of trying to communicate across the vast darkness, is itself meaningful. It shows that we're capable of thinking beyond ourselves, beyond our immediate needs and fears, toward a future we'll never see but can still shape. This brings me to another layer of the mystery. Not just whether there's life out there, but what form it might take. We tend to imagine aliens as biological beings, creatures with bodies and brains, not too different from us. But life might be far stranger than that. On Earth, life is carbon-based, built from complex molecules like proteins and DNA. But carbon is not the only element capable of forming complex structures. Silicon, for example, can also create long chains and networks. Could there be silicon-based life on a high-temperature world where carbon would break down? We don't know. We've never seen it. But the chemistry is theoretically possible. And what about non-biological life? What about artificial intelligence? Machines that think and feel and create. On Earth, we're already developing AI systems that can learn, adapt, and solve problems. They're not conscious, not in the way we are, at least not yet. But they're getting more sophisticated every year. Some scientists believe that within this century, we'll create artificial general intelligence, AI that can match or exceed human cognitive abilities across the board. And once we do, that AI might improve itself, becoming smarter and smarter in a rapid feedback loop. This is called the singularity, and it's one of the most profound and unpredictable events that could happen in the future of our species. If we can create artificial intelligence, then surely other civilizations, if they exist, could do the same. And if they have, then the galaxy might be filled not with biological beings, but with machines, descendants of organic life, that long ago transcended their biological origins. These machine intelligences might not need planets. They might live in vast computational substrates, in clouds of self-replicating nanobots, in structures we can't even imagine. They might communicate through gravitational waves, or quantum entanglement, through channels we haven't discovered yet. They might not be interested in us at all because we're too slow, too primitive, too tied to the constraints of biology. This is a humbling thought. We think of ourselves as intelligent, as advanced, as the pinnacle of evolution on Earth. And compared to other species here, we are. But on a cosmic scale, we might be infants, just barely beginning to understand the universe. A civilization that's 1 million years older than ours would have technologies and concepts we can't even conceive of. The difference between them and us would be greater than the difference between us and ants. And just as we don't spend much time trying to communicate with ants, advanced civilizations might not spend much time trying to communicate with us. We might simply be beneath their notice, too undeveloped to be interesting. And yet, despite all this uncertainty, despite the vast silence of space and the strangeness of possible alien minds, I remain hopeful. Because the universe has already given us so much. It gave us atoms and stars and planets. It gave us chemistry and biology and consciousness. It gave us beauty and music and love. It gave us the ability to look up at the night sky and wonder. That, in itself, is extraordinary. That, in itself, is enough. But let's shift our focus now from the possibility of other minds to the reality of our own. Because while we search the stars for signs of intelligence, we often overlook the miracle of consciousness right here, right now, in our own heads. You are conscious, you know that because you're experiencing it. But how? How does a collection of atoms, arranged in a particular way, give rise to the feeling of being someone? How does matter become mind? This is not just a philosophical question, it's a scientific one. Neuroscientists are actively working to understand the neural correlates of consciousness, the specific brain activities that correspond to subjective experience. They've discovered that consciousness is not located in a single region of the brain, but emerges from the integrated activity of many regions working together. The prefrontal cortex, the thalamus, the posterior cortex, all of these areas communicate, sending signals back and forth, creating feedback loops that give rise to awareness. One theory, called Integrated Information Theory, or IIT, proposes that consciousness is a measure of how much integrated information a system contains. The more interconnected and differentiated the information processing, the higher the level of consciousness. According to IIT, even simple systems like thermostats have a tiny bit of consciousness because they integrate information, but their consciousness is extremely low because the integration is minimal. Human brains, with their billions of neurons and trillions of connections, integrate information at an extraordinarily high level, which is why we have rich, complex, conscious experiences. Another theory, global workspace theory, suggests that consciousness arises when information is broadcast widely across the brain, becoming available to many different cognitive processes at once. According to this view, most of what the brain does is unconscious, happening in specialized modules that work in parallel. But occasionally, information from one module gets amplified and broadcast to the whole brain, entering the global workspace, and that's when it becomes conscious. Consciousness, in this model, is like a spotlight, illuminating one small part of the brain's activity at a time, while the rest remains in darkness. Both of these theories are attempts to bridge the explanatory gap between brain activity and subjective experience. And while neither has been definitively proven, both have generated testable predictions and sparked productive research. What's clear is that consciousness is intimately tied to information, to the way the brain processes and integrates data from the senses, from memory, from internal states. And that information processing is, ultimately, a physical process, governed by the same laws of physics that govern everything else in the universe. This leads to a startling conclusion. If consciousness is physical, if it's the result of information processing in the brain, then it's not fundamentally different from other physical processes. It's not separate from the material world, it's part of it. And that means that, in principle, consciousness could be studied, understood, and even replicated. We could build machines that are conscious. We could upload minds into computers, preserving consciousness beyond the death of the biological body. We could enhance our own consciousness, augmenting our brains with technology, expanding our cognitive capacities beyond their natural limits. These possibilities, once the realm of science fiction, are becoming increasingly plausible. Companies like Neuralink are developing brain-computer interfaces that allow direct communication between neurons and machines. These devices could help people with paralysis control prosthetic limbs or communicate through thought alone. But they could also, in the future, allow us to interface with AI, to access information instantly, to think faster and more clearly. The boundary between human and machine is starting to blur, and as it does, we'll have to grapple with profound ethical and existential questions. If we augment our brains, are we still human? If we upload our minds, are we still ourselves? Where does the self reside? In the body? In the brain? In the pattern of information that makes us who we are? These questions don't have easy answers, but they're worth thinking about because they get at the heart of what it means to be conscious, to be alive, to be you. Your sense of self, your feeling of being a continuous person over time, is itself a construction of the brain. Studies of patients with brain damage have shown that the self can be disrupted, divided, or altered. People with split brain syndrome, where the connection between the two hemispheres is severed, sometimes exhibit two separate streams of consciousness, each controlling one half of the body. People with certain types of amnesia lose the ability to form new memories, living in an eternal present where every moment feels new. People with conditions like Cotard's delusion believe they're dead, that they don't exist, even though they're clearly alive and aware. These cases reveal that the self is not a fixed, unchanging entity. It's a process, a story the brain tells itself, constantly updated and revised. And that story is shaped by memory, by emotion, by sensory input, by social context. You are not the same person you were 10 years ago. Your cells have been replaced. Your memories have changed. Your beliefs, your values, your relationships, all of it has evolved. And yet, you still feel like the same person. That continuity, that sense of being a single, unified self moving through time, is one of the most powerful illusions the brain creates. And it's an illusion we need. Without it, we couldn't function, we couldn't make plans, form relationships, or navigate the world. So here we are, beings made of star stuff, conscious and aware, living on a small planet orbiting an average star in a vast universe. We don't know why we're here. We don't know if there's a purpose to our existence. But we do know this. We're here now. And we have the capacity to experience beauty, to feel wonder, to seek understanding. That capacity is precious. It's the most remarkable thing the universe has produced, as far as we know. And it's worth celebrating, worth protecting, worth nurturing. When I think about the future, I feel a mix of hope and uncertainty. Humanity faces enormous challenges: climate change, political instability, economic inequality, the threat of nuclear war. These are real and serious. But we also have something our ancestors didn't. We have knowledge. We understand the laws of physics, the chemistry of life, the structure of the cosmos. We've sent probes to the edge of the solar system, landed rovers on Mars, detected gravitational waves from colliding black holes. We've mapped the human genome, cured diseases, connected the world through technology. We've created art and music and literature that capture the depth and complexity of the human experience. And we've begun to understand our place in the universe. We know that we're not the center, that Earth is just one planet among billions, that the Sun is just one star among hundreds of billions, that the Milky Way is just one galaxy among trillions. We know that we're made of the same stuff as stars, that our atoms were forged in cosmic furnaces, that we're part of a vast, interconnected web of matter and energy stretching back to the Big Bang. This knowledge is humbling, but it's also empowering, because it tells us that we matter, not because we're special or chosen, but because we're part of the story. We're the universe becoming aware of itself, and that's an extraordinary thing. So as we continue to drift through this meditation, as your breathing slows and your thoughts begin to settle, let yourself feel that connection. You are not alone. You are part of something vast and ancient and beautiful. Every atom in your body has a history that spans billions of years. Every thought in your mind is the product of a brain shaped by millions of years of evolution. Every emotion you feel is a message from deep within, a signal from the complex system that is you, trying to navigate the world, trying to survive, trying to thrive. And when you dream tonight, when your brain creates its private universe of images and sensations, remember that you're participating in one of the most mysterious processes in all of nature. You're experiencing something that might be unique to conscious beings, or might be a fundamental feature of reality itself. Either way, it's a gift. Consciousness is a gift. Life is a gift. And the universe, for all its vastness and indifference, has given us the ability to appreciate it. So rest now. Let your mind wander through the stars. Let yourself drift on the currents of thought and memory. Let the weight of your body sink into the surface beneath you, knowing that you're supported, you're held, you're part of the great turning of the cosmos. The universe is spinning, always spinning, and you're spinning with it. You're moving through space at incredible speeds, and yet you feel still. That stillness is not emptiness. It's peace. It's the harmony of everything moving together, the quiet rhythm that underlies all existence. And as you fall asleep, as consciousness fades into the soft darkness of dreams, know that you'll wake again. The sun will rise, light will return, and you'll open your eyes to another day. Another chance to wonder, to explore, to connect. Another moment in the long, slow dance of the universe. And in that moment, you'll be exactly where you need to be. Right here, right now. Part of everything. Made of stars. If this quiet journey has brought you peace, I'm grateful beyond words that you've shared this time with me. A gentle like or a soft subscribe would mean the world, as it keeps this small sanctuary alive for those who seek wonder in the dark. And if you're moved to share, tell me in the comments where you are tonight and what time it is. I love knowing how far these whispers travel, from one corner of the world to another. Your presence, your words, even your silence, they all matter deeply. Until we meet again, may the cosmos hold you gently, and may you always remember that you are made of stars. Good night, and thank you for drifting through the universe with me.